go to page 166 of your journal and enter the definitions for logarithm of y with base b function, common logarithm, and natural logarithm. And then if you look at the definition below in the core concepts, you can see we have log base b of y, and that's defined as b to the x equals y. Now I want you to go to your packet to 6.3 and look at example 1. Remember, log base b of y equals x and b to the x equals y are the same thing. The b is the same, the x's are the same, and the y is the same. So for these parts, we're going to rewrite log base 2 of 16 equals 4. I'm rewriting part A. And then in exponential form, that's just 2 to the 4th power equals 16. So let's rewrite each part and then write it in exponential form. So for part B, I have 4 to the 0 power equals 1. Part C, I have 12 to the 1st power equals what? 12. I have 1/4. I'm going to put that in parentheses since it's a fraction. To the negative 1 power equals 4. And then if you go down to example 2, we're doing the same thing, but in reverse order. So I'm going to rewrite A, B, C, and D. So I have 5 squared equals 25. 10 to the negative 1 equals, this is really 1/10, but 0.1 is the same. 8 to the 2/3 equals 4, and 6 to the negative 3 equals 1/216. So if I rewrite these in log form, I'll have log base 5 of 25 equals 2. Make sure your exponent is always your answer with the log. So this next one is log base 10 of 0.1 equals negative 1. What will part C equal? Log base 8 of 4 equals 2/3. So again, your exponent is always your answer. So what will part D equal? Log base 6 of 1/216 equals negative 3. Good. Now go to example 3, and you can read this part up top, but we're going to look for the answer to this log. To do that, I'm going to say let this equal x, and say 4 to the x power has to equal 64. Well, let's make it the same base. So 4 to the x equals, I know this is 8 squared, but I don't want 8, I want 4. So this is 4 to the 3rd power. Therefore, we can see x is going to equal 3. So this answer is 3. And then let's look at part B. If we do the same thing, set this equal to x, we're going to have 5 to the x power equals 0.2. You should know that this is actually 1/5. So 5 to the x is 1/5. And if I just want the 5 to come up to the top, I know that means it's 5 to the negative 1 power. So then x equals negative 1. For this next one, I'm going to have 1/5, that's my base, to the x equals 125. So for this one, it's a little strange, but I want to change this 1/5 to 5 to the negative 1 like I did in part B. And I'll have 5 to the negative 1x equals 125 is 5 to what power? Yeah, the third. So then negative x equals 3, which means x equals negative 3. So the answer is negative 3. Okay, that's negative 3. I'll write it again down here. And then this last one, if we make that equal to x, I have 36 to the x equals 6. And to do that, I know that 36 is 6 squared. So this is like 6 to the 2x equals 6 to the first. So then set 2x equal to 1, divide both sides by 2, and you get x equals a half. So the answer to this is 1/2. So now look at example 4, and we're going to evaluate log of 8 and ln of 0.3 using our calculator. We want to round to 3 decimal places. So if we put log 8 in our calculator, we get 0.903. And for part B, if you put ln of 0.3 in the calculator, you get about negative 1.204. If you're not sure where these buttons are tomorrow, I can help you with that, so just let me know in class.